Hello and welcome to Technically Speaking, a podcast where scientists and engineers come together to chat about a common interest, share knowledge and satisfy some curiosity. I'm Laura, and in this episode I'm joined by Ellie to talk about materials that mimic things from nature and speculate on what we could use these things for. So, Ellie, I know you have a zoology background, so what do you know about mimicry in nature?
Hey Laura, when you first came to me with this idea, I got completely the wrong end of the stick and went full zoology. And I was like, oh yeah, Batesian mimicry, Malarian mimicry. I did this at Reading, like during my degree. I know all about this, I'll be fine. And then you were like, oh, actually, no, we're doing the materials bit. And I was like, right, this is not quite what I had in mind. But I've done my research. And in the interest of definitions and explaining for the uninitiated, like myself, I'm going to start with the zoology thing that I thought we were doing, and then I'll move on to what we're actually doing, if that's okay.
Yeah, that sounds good.
So the way I understood it, Batesian mimicry is one type that I definitely learned about during my zoology degree. And it's basically when you've got a snake, let's say, that's venomous, and it'll be really bright colours. So let's say it's red and black, and that snake is venomous, and predators know not to attack that snake because it will taste horrible, and it's not going to be a good meal for them. And then a second snake will evolve those same colours, but without the venomous, noxious streak, and then benefit because the predator will avoid eating them both. So then it's mimic the colours. It doesn't have the toxicity, but that benefit has helped it survive.
Yeah.
And will keep it safe.
So that's what's happened in the natural world.
Exactly.
But that's not what happens in material science.
Also true. So the one we're actually doing is taking ideas from nature and developing them into materials, into technology that we can use to make our lives better, our experience better, and exploit the same niches that these animals are exploiting for our own sort of gain, I guess, really. Sort of being inspired by nature, I guess, is a better way of putting it.
Yeah.
To do different things and make different materials.
Yeah, and to me, so I do sort of general science. I'm not necessarily a material scientist. But yeah, it's about designing physical things that we can use that are modelled on biological structures and processes. I mean, I did my PhD in looking at atoms. So to me, it goes right down to how the atoms are arranged to give something certain properties. So I guess an example is how diamonds sparkle because they have those internal faces. That's how to do with how the carbon atoms are lined up to create that surface and then reflect light back at us. There are other materials that are not as hard and shiny that we can talk about.
I'm glad because you just said diamonds have internal faces and I was like, I'm sorry, what now, please?
Like little animal face.
They're just smiling like between each other or...
Yeah, diamonds have emotions. That's
a takeaway, guys, if you learn nothing else.
But we were having a look into, so what materials have people created that mimic something in nature? Someone in the team suggested Velcro.
Well, the guy that developed Velcro was quite a fan of hunting, and he used to go like on hunting trips in the wilds with his dog. And he hiked up to this hunting lodge, and he noticed that his dog was covered in burrs from plants. Absolutely ridiculous, like tangled in the dog's fur, couldn't get them out, absolute nightmare. But he was inspired by how well they stuck to create Velcro, which is essentially the same thing. It's the hook and the eye like material that connects together that makes it really sticky. And it was all inspired by the burrs from the plants that got stuck in the dog's fur.
The burrs are like little bits of plant that have got these little hooks on them, right?
Yeah, exactly.
Yeah, I have experienced this exact same thing. We got a puppy 5 months ago now. Not long after we got him, we took him out for a walk in the forest. So walking along a forestry track, he can't really get too far away from us. Bounding off into the trees, comes back, sits on the path quite away from us and just like, I'm not happy, I'm just going to sit here. I'm like, I'm not walking back to you, dog. You're going to come here. And he did this funny, strange walk with his legs all flailing around. What is wrong? He was completely covered in burrs.
In the burrs?
Yeah, we could not get him off him. These little, I think they were like the heads from thistles that had died because it's obviously autumn when we took him out. And yeah, they had these little hook things that just, I mean, they were sticking to my fingers as well.
Yeah, they're really sharp. Or they can be, depending which ones you get.
Poor dog, we had to make him walk home, still covered in them.
Oh, bless him.
And we had no choice but to cut his fur to get them off him.
Yeah, I think that's what a lot of people have found, that they are, well, they're doing exactly what they're designed to do. in that they're spreading the seeds so that they attach onto, in this case, your dog, but it could be any animal, and then go away, like disperse as far as possible in the hope of growing all these new plants. And yeah, unfortunately, you can't get them out. I mean, eventually in the wild, like they would drop off to be planted. But yeah, in this situation, they got intercepted by a 5-month-old puppy.
Yeah, I just have visions of all these like really long-haired animals because our puppy's got fur. It's probably several inches long, like maybe 10 centimeters or so, just covered head to toe in seed pods, and they're just like walking seed menageries.
But basically, yeah, this is the whole point of like, it's from nature. Like nature has perfected the art of spreading these seeds as far as possible and making it sticky so that they can go far. We've just now adapted that, or the guy with the dog in the hunting lodge developed Velcro to make stuff stick.
You know, it's funny that I could have sworn I had read Velcro was invented by NASA, but you reckon that's not true. You say you looked at the Velcro website and they explained the real story about this hunter.
Yeah, but this is a thing, this NASA misconception. So I don't know whether NASA's like trying to claim Velcro for its own, or whether this guy like was actually daydreaming and like came up with it and then sold it to NASA. I have no idea, but as far as I understand, and according to the official Velcro website, it was the burrs in the dog fur, and it wasn't some kind of impressive material invented by astrophysicists for use in space stations.
Yeah, people that just want to stick to things when they don't have gravity holding them down. I'm not saying NASA doesn't use Velcro, and they have invented quite a lot of really useful things, but Velcro's not one of them, apparently.
Yeah, I expect they probably use Velcro quite a lot, but I don't think they can claim that they were the original inventors of Velcro.
Someone's spreading lies.
False news.
Yeah, and I mean, so Velcro is kind of like you can see those hooks and those loops. You can kind of see how they work. But I was also reading about wetsuits that are made in a way that emulates shark skin. And I really like this idea because I'm quite outdoorsy, but I'm not a very good swimmer. So anything that could help me swim would be great, I reckon.
I love this. I think this is one of my favourite examples of this. So basically, great white sharks, masters of the ocean, can swim really fast, really stealthy. And shark skin is basically covered by like tiny little V-shaped scales, all like laid on top of each other. And imagine like a bit like roof tiling, like all these little scales.
Yeah.
The way that they're designed is that the drag and the water resistance and the turbulence is so much reduced because you can just imagine the water like flowing over the scales that they swim faster. Then, you know, material scientists, Olympic swimsuit designers have taken this idea and made exactly the proportions of the shark's denticles into like wetsuit material. Hey presto, your Olympic swimmer is breaking records all over the place and, you know, swimming faster and so much more efficiently, and then conserving energy to, you know, put in the final sprint at the end of the race.
Yeah, I love that word, denticles. Always makes me chuckle.
I have never seen it come up in any other situation, but it must. Other animals must have denticles.
So I'm thinking of octopi and tentacles, and that's not the same thing at all. But I had seen a research paper on this, and these denticles are really small. They'd used an electron microscope that sees things that the human eye can't see to get an idea of their shape. Do you have any idea how big these denticles are?
Wow, okay. I'm going to go. If we're talking electron microscope now, so this is taking me back.
Well, you can see micrometer things by eye, so it may be smaller than that, but then you can see micrometer things in an electron microscope. I don't know why they were using an electron microscope.
I'm going to go half a micrometer.
This research paper was also saying the mechanism that sharks use to make the denticles work doesn't actually work on humans because they're connected to this flexible membrane. It's more flexible than the swimming suit when it's on a person, and it's something to do with the flexibility that makes the denticles wave around.
Wow.
That creates these little vortices around them that mean they have less drag in one direction.
So actually, unless you're an Olympic gymnast as well as an Olympic swimmer, you've got no chance.
It was saying something about there are probably other reasons why these swimsuits make Olympic swimmers go fast. Like they really compress things and they make you a bit more rigid and things like that. But apparently the shark skin thing is a bit of a myth. It's a nice idea, emulating shark skin, but apparently it's not how the Olympic swimming suit worked before. I think it was banned, wasn't it?
Was it banned? Wow. I was going to say if it didn't really work that well, then maybe it's just like a placebo effect. Like if you tell someone you're going to swim faster because I've made this swimsuit out of shark skin, do they swim faster knowing that, where in reality you've just stuck a few scales on it and called it a day?
How interesting that, yeah, the idea that you say, oh, this magical swimsuit will make you swim
I'm actually
faster.
shocked. I feel like I've been lied to.
Yeah, I mean, there might be different brands of shark skin inspired swimming suits. They might all work slightly differently. But yeah, there's this one, I think he was a professor at Harvard. It's about 10 years ago this paper was published. It got some of these wetsuits from shops and did a load of analysis and compared it to how shark skin works, which no one's entirely sure how it works apparently, because,
Oh, wow.
you know, you're not going to do a lot of experiments on sharks, are you?
Well, you could try. I don't think anyone's, volunteering to then race the shark, are they?
Oh, that would be an interesting race, though. You'd be very motivated.
You don't need the placebo effect. You just need an actual shark in the bottom of the pool. And then we'll see how fast you can swim.
That's how Olympic swimmers really train.
I refuse to give sharks a bad name, though. Shark attacks are very rare. They would make me swim faster if I saw one.
Yeah, I agree. Apparently, cows kill more people than sharks do. Now, obviously, you're more likely to, well, I'm more likely to encounter a cow than a shark. It's no surprise.
Yes, there is an element of I don't see a shark on a daily walk, but I might see a cow.
So if shark skin has this texture, these tentacles that are on a, we think, micron scale, I was also reading about gecko feet that use an even smaller length scale. Much like Velcro, they're sticky, but in a different kind of way. Have you read anything about those?
Yeah, so I was looking at this. It went down into your favourite atom level science way of describing it. But basically, gecko feet aren't sticky. It's not like an octopus tentacle. It's not a suction cup. It's basically tiny hairs that react to light, is how I understood it. And then it kept going and it said something about Van der Waals forces. And I lost it a little bit because that's probably 10 years ago that I did that in A-level chemistry. But tiny gecko feet having hairs, making them climb up glass and like light surfaces is to do with the light refraction. I couldn't tell you exactly how it worked, but it's something along those lines.
Oh, I hadn't come across the light reflecting properties. I get how the Van der Waals forces work because they're just atomic forces that either attract or repel things. And I'd seen that someone had used this to design something that humans could use to climb plate glass windows, apparently.
I'm thinking, like James Bond, Mission Impossible, up the side of a skyscraper using gecko feet technology is the way forwards.
Yeah. And we mentioned this in the skyscraper episode that we did with Rueda a few months ago, that it was Mission Impossible Ghost Protocol, I think. Tom Cruise climbing up the Burj Khalifa, tallest skyscraper in the world, using these sticky pad things that I guess are meant to be like gecko feet. Apparently the actual technology doesn't look quite the same as that was used in the film. They're these little sort of platformy things that
you put your hand in and lift.
It was described as it's like climbing up a staircase. They sort of stick and you put your feet on them, and then when you move them in a certain way they just unstick. So it's like walking upstairs but with a plate glass window in front of you several 100 meters in the air.
Yeah, I'm not volunteering to test that one. The shark skin wetsuit maybe, but there's no way I'm climbing the Burj Khalifa.
I agree. That would probably terrify me. I like having my feet on the ground, and even though I think I'd probably trust the technology, I think I'd just panic and not trust my own ability to move my feet. just be plastered to the wall.
I know the science of how this works, but it doesn't mean I'm going to go up using it. We'll send Tom Cruise up. He can test it for us.
I swear I've also seen my pet rats do something similar. So we have a lamp in the living room that's got a metal pole, one of those floor lamps, and it stands sort of head height-ish. And my rats run around in the evening in a little pen that comes up to sort of mid-thigh height. And they'll jump up on top of this pen, and Rocket was looking around. Rocket and Groot, Guardians of the Galaxy.
Incredible. I love that. I think Groot really is the best one, isn't it? Rocket and Groot, if you can have names from Guardians of the Galaxy. That's where you want to go with them.
And they suit their names as well. They have personalities that match those two characters in the films. Rocket, obviously being the braver one, is looking around like, I want to go on that chair. There's a pole here. I reckon I can climb on that pole and use that as a midway point to then climb onto the chair. And I just expected that once she lifts all 4 feet and her tail off the barrier that she was standing on, that would be it. She'd fall to the floor because it's this sheer, shiny metal pole. But no, she just hung there as if she was incredibly comfortable with her little tail wrapped around it, gripping on.
Oh, I feel so proud of her.
I was just amazed by her, and then I had to tell her off.
Get back in you. Now, I watch the squirrel pretty much every day will come into the garden, shimmy up the bird feeder pole, wait on the seed tray, have a look around, and then climb all the way to the top. And some days he can do it fine. And some days he's doing the fireman's pole slide dramatically back down to the floor. I should film it really because it's so funny.
Oh, that does sound great. So yeah, I wonder if rat tails, because they're a little bit scaly and they do have little hairs. I wonder if they work in a similar way to maybe not gecko feet, but maybe Velcro that helps them grip. Because those hairs definitely they're quite stiff and they go in one direction.
That's so true. I've never thought of that. That rat tails are minimally hairy compared to the body of a rat.
Yeah.
But then why would that be? And maybe, yeah, it's something to do with balance or grip.
Yeah.
Because they do climb a lot, don't they?
They do, and yes, squirrels obviously climb up trees and they dig their claws in, and they've done this to me when I've been feeding them in the park, and they're quite very sharp.
Yes.
But they've got very furry tails, so I guess that's not as good for grip unless you're getting burrs caught in them.
Yeah, depending what you want to achieve based on how furry your tail is.
And something else, I think we were both reading about this. I think you brought it up originally in our WhatsApp chat, was insulation that's inspired by squid skin.
Yes. The problem that they wanted to solve was that when you get given a coffee cup, you want your liquid coffee to be hot, but the outside of the cup to be cold so you don't burn your hand holding it.
Yeah.
And apparently, squid skin is a really good insulator for doing that. And I couldn't quite work out how, but it's something to do with like squid skin can change color and like manipulate light. And in doing so could be hot on one side and cold on the other. So then your coffee would be hot, but your hand wouldn't be burned. I think this is a really interesting example. But then also I was thinking, would I want a squid skin coffee cup? And then the answer was probably no, but unless you could mimic the material and not actually use the squid skin itself in the coffee cup structure.
There was a research paper published this year, last month, I think, March 2022, about specifically the coffee cup example. And it's based on another paper that the same research group published in 2019. So it's squid skin inspired, but doesn't actually have squid skin in it.
Excellent.
I feel like this is turning into a lot of tongue twisters.
Shark skin wetsuits and squid skin coffee cup.
Do you remember from your degree, or were you taught how squid skin adapts its colour?
No, is the short answer. I mean, I've seen, you can watch videos of them doing it. You know, people doing like research experiments on making like squids and cuttlefish and octopuses all change colour, which is really cool. But then how that would translate into heat, because I thought squid skin, I think of squids as being cold for no good reason, just because they live in the ocean. But there's no reason that they would be cold or that they wouldn't need to retain heat in some way to keep them going. But then obviously the ocean is quite cold. So it's really intriguing to me how that they've worked this out and how this would be actually applied to a material that could mimic this.
So I wonder if the way that it's been mentioned in the news has made it sound slightly confusing, like squids are able to insulate themselves. They use these things called chromatophores in their skin that contract or relax using muscles, I think. And it's the size of that chromatophore that makes it change colour.
Oh, amazing.
If that chromatophore is just a blob of pigment and you stretch it out, then obviously it makes a bigger blob. The way that the insulating material works is a similar-ish sort of thing in that when you stretch your material, this heat reflective layer is made of all these little, I'm going to call them flakes. They didn't call them that in the research paper, but I find that a lot easier to visualize. The flakes spread out and create these gaps in between them, and those gaps allow heat to move. And then these are sort of nano or micro sized things, less than a micrometer on a side. So again, we're talking about really small length scale. The way that it stretches is literally you apply mechanical force, so it's the same as the squid flexing whatever muscles to make those chromatophores bigger or smaller.
Oh, wow. So it's all to do with literally just stretching it.
Apparently, it sounds really simple, doesn't it? You'd never think of just stretching a material to change its insulating properties.
I would only think, I'll stretch it, then it'll be thinner, and then more heat will escape through it because the barrier is then less. But yeah, it's the exact same principle. If you stretch it, you can change that. That's amazing.
What I find a bit crazy is that they want to use this for food packaging and for coffee cups, and that just seems like a really mundane application of this really innovative way of thinking about how to design a material.
We must use it for coffee first, and then we'll have the caffeine to think of what else to use it for.
The cynic in me says they must have got funding from a packaging company.
Oh, maybe it was NASA.
Oh, maybe. But see, that earlier research paper, the one from 2019, was talking about wearable things based on space blankets to keep you warm and help regulate body temperature.
Wow, so it's all linked. This is a conspiracy.
Yeah.
This is a squid skins conspiracy by NASA. They've been jilted on the Velcro, so now they're coming back strong. They want their own biomimicry material.
Yeah, I feel like there's a joke in there about squids from space that can also change colour as well as regulate heat.
When we contact alien life, it'll be the squids that are angry first.
Linking back to our previous episode where we were talking about solar cells, the original research, they started off using essentially silicon chips to build these materials onto. So like deposit a layer of copper and then deposit this polymer on top, and it's the polymer that's stretchy and it's the copper that reflects the heat. But I read the research paper and thought, hang on, silicon chips are really pure silicon is what you start off with. That's really expensive. That's some expensive coffee cup insulation that you've got there.
That's so true. I was just thinking, like, Velcro is cheap because it's everywhere and it's made of plastic, and shark skin wetsuits can probably afford to be expensive because not everyone is buying them. If you're a serious swimmer, that might be something you invest in. But coffee cups are everywhere, much to their own detriment. And if we're going to make them extra fancy and extra good, we need to also make them recyclable at the same time, or biodegradable, or both, or sustainable. All of these buzzwords that need to be involved.
I agree. And when I dug into the more recent paper from this year, they did say that they'd swapped out the silicon for aluminium, and they do remove it from the aluminium afterwards. So it does make it cheaper. But apparently the copper layer they put on is quite thin. Sort of, I think, nanometers thick. It dissolves in just vinegar.
It dissolves in vinegar.
So hang on, this food packaging that you want to make.
If I'm eating my fish and chips on the beach and I'm pouring vinegar, my whole thing just dissolves.
Maybe you do have copper in your diet and you need a little bit of copper in your body, so it might be fine. But some people are also allergic to copper.
Ooh.
I don't know if there'd be enough copper in your food packaging insulation to be high enough concentration that you would develop an allergic reaction if you are allergic. But I think there are some other things to consider. But apparently it is recyclable because you can just dissolve off the copper and then recycle the plastic it's been attached to.
I mean, perfect, maybe, depending.
I think I'll be sticking to just using a cardboard sleeve.
I think that would probably also work as well, if not better, than all this extremely complicated fancy technology.
Just go simple. Cardboard's recyclable and we've been using it for a while and it biodegrades.
So I've got a few little mini examples of different things that are inspired by nature. When the Japanese developed their super fast high-speed trains, it was all great, it was all going really well, except for the fact that when they came out of tunnels, they had like sonic booms, and it was super loud and very annoying for everyone in the area because these huge trains are making an absolute racket. So they took inspiration from the kingfisher, and if you've never seen one, kingfishers are exactly what it says in the name. They sit on the edge of a riverbank on a branch, and they've got beautiful pointed beaks and bright blue feathers. I mean, there's lots of species, but the ones in England are bright blue. And they dive and they fish in the water. And so that beak hits first, and that long, slender beak means that they can go into the water with very little disturbance. So the Japanese saw this and they modelled the front of the train on a kingfisher beak and made it really long and thin. And apparently that then fixed the like sonic boom noise problem by like reducing the drag and the change in pressure, I guess, as it came out of the tunnel back into the normal landscape. And it was all thanks to the kingfisher.
I would have thought when they go into the tunnel, because you're moving the air out of the way, right? You're pushing the air around the train. And when you go into the tunnel, I'd have thought you can't push the air out of the way because the tunnel walls are in the way. Was that something else they had to figure out, or am I thinking about that in totally the wrong way?
I don't know now, and now I'm doubting myself whether it was into or out of the tunnel.
Guess when you come out the tunnel, there's still a pressure change. So there must be something going on there.
So they're travelling super fast, and they generate the noise that could be heard 400 metres away to changes in air resistance. When the train's entered the tunnel, creating low frequency atmospheric pressure waves. So then they redesigned them to match. So it was going into the tunnel, not coming out of. So you were right. But also it made them 10% faster and use 15% less electricity, according to this article. So thanks to the Kingfisher for speedy rail travel.
That's cool. So I like how we started off with sort of a thing you can hold in your hands, and then we went stupidly small to things you can't even see without special equipment. And now we've gone really, really big sort of engineering scale. Here's how trains are inspired by nature.
I love it. Everything should be inspired by nature because clearly it's just doing it better. We can't come up with our own ideas. Let's just steal it from the animals that are doing it really well in the first place.
They've had so much time to evolve and fit into, you said, that niche, that part of nature that nothing else is doing something in.
Exactly.
Why not make use of that evolution?
I've got another big one for you. And I'm not entirely sure how far they've got with this, but wind turbines, you know, the big blades.
Yeah.
Someone has been whale watching and looked at the fins of a humpback whale and seen that the edges are not smooth. They're in fact really bumpy on purpose, like through evolution, and then has used this bumpiness to create a new kind of wind turbine blade inspired by the bumpy humpback whale fin that is actually more efficient and just better at like spinning around and achieving, I don't know, higher quantities of electricity production, I guess, is what their ultimate aim through. I think it's still in testing, but this is what they want to do, or what they were definitely thinking of at one stage.
Cool. Yeah, I feel like we've moved a little bit away from the materials thing now because we're talking about trains and turbine blades. That's cool. It's nature-inspired mechanics, I guess.
Yeah.
Yeah, that's something that could be really useful because I've heard that wind turbines aren't actually all that efficient at converting kinetic energy from wind into electricity, but I have no idea about the details. There's a lot going on with wind turbines. I think one of my favourite mechanical nature-inspired things is shock absorbers that are based on woodpecker heads.
Oh, now we're talking.
And we've been getting woodpeckers in our garden for years, and yeah, watching them hammering into that tree, it looks like it shouldn't be able to survive that. But it's to do with how the head is constructed. There are like 4 different components, like a spongy-ish beak and then some fluid, and the way that the skull is constructed as well makes it really good at absorbing that shock.
It would need to be, otherwise you just see woodpeckers falling out of trees the whole time, giving themselves concussion.
How cool is that there's this evolution that allows woodpeckers to do things that should probably kill you.
But you're okay. So what are we putting it in?
The example I saw was for keeping electronics safe, so like black box recorders on planes, so when a plane crashes, that evidence will still be intact. I think that Apple should capitalize on this. The amount of iPhones I have broken in some way through dropping them on the floor.
This is going to be our £1 million idea. We can make phone cases based on woodpecker head shock absorption, patent it. We'll be millionaires, Laura. This is the idea we've been waiting for.
Oh, we'll have to get in there, get in the lab and do some research then. Or just talk to some people, say, we've got this great idea. Don't listen to our podcast until we've told you about the idea and agree to it.
If you're hearing this, we've not been able to patent it.
It does make me think, like, what else might we want from nature? Whether it's a material or something else that we want to mimic.
Call me crazy, but I have always wanted a tail. Because think of like a cheetah or any kind of monkey, anything like that. Like the ability to have a tail that like super duper helps your balance. Because I fall over and trip over the whole time. And I just think if I had a tail, I'd be like that little bit more stable. And then if I had like a proper prehensile one, I could grab onto stuff like right at the last second. And then I wouldn't, like, just before Christmas, I fell down the stairs at my mate's house because I slipped because I was wearing tights on their like new carpet. If I'd had a tail, that reaction, I could have grabbed the banister. I would have been fine.
That makes sense, yeah. I could see having a tail. I can do what my rats do, maybe. I don't know if that'd scale to tiny little hairs holding a human up.
I'd be really great at like, what do you call it, Total Wipeout and all those games. Just an extra limb, basically, is what I need.
Yes, I think they'd have to make a special category of Total Wipeout for people with tails.
Oh, then we could pit them all against each other. You could have the person with the cheetah tail, the person with the monkey tail, the person with like the lemur tail. It would be great. I would pay to see that. What would you have?
I'm a big outdoors person, so I can see that the squid skin insulation we were talking about, I can see that I would have a use for that in the outdoors. So rather than having to constantly take off layers or put on layers because it gets a bit windy or it gets sunny,
Yeah.
I just have clothing that adapts. That would be great. So something else I would want for the outdoors is to be waterproof. I mean, I know human skin is waterproof, but then you need clothing to keep you warm, and then that gets wet, and then you get cold.
Yeah.
The waterproof clothing that is currently out there, it works all right, but it's not that breathable, and I get quite sweaty.
So basically, you need feathers. You need to be like a gannet or a water bird, and you need that runoff so that you are warm, insulated, but not like soaked through, and then obviously not hot through all the layers. Or you could go like seal and just have like an intense layer of blubber. But that might not be so good if you're like hiking up mountains.
No, it's again competing with the temperature differences as well. It's not particularly warm because I live in the Lake District in the north of England, or near the Lake District. So it doesn't get incredibly hot a lot of the time, but it is very humid. I was reading about lotus leaf inspired paint. Something about the lotus leaf, it's got a layer of wax crystals on it and it's really rough. And something about that combination of wax and surface roughness means that water just doesn't really want to stick to it. It's super hydrophobic, so the water just forms these beads. They look like almost like spherical droplets, just almost floating on the surface. So I wonder if that could be used in some way while still being breathable.
You could definitely sell that to like North Face or someone like that, because you have those materials like water repellent trousers and that sort of thing, where if you pour like a glass of water, it will like bead and run off and it won't soak into the trouser. But I do feel like there's a limit with those, that eventually it just soaks through. Like there's only so much water repellents you can do it before it.
They also get dirty, and apparently this lotus leaf inspired paint also repels dirt because it doesn't want to stick to that surface, and then the water just washes it off. So you'd be waterproof and clean. You'd never have to wash your outer layer of clothing.
Amazing. I also really want retractable claws. If you're in the kitchen and you're making spaghetti bolognese and you've got your mince in a thing, there is no way on earth you are opening that mince packet perfectly from the little peely corner.
That is true.
First time. It's not going to happen. So then you're like looking for a knife or scissors. No, retractable claws, shing, proper Wolverine style. Straight open, maybe even just one. I don't need the full set. I just need one really sharp claw, and then cutting open boxes, delivery parcels, you name it, shing, straight open, retractable claws, like a cat.
Practically, you might not be allowed on a plane ever because you're always carrying a weapon.
I'm just incredibly dangerous now with my tail and my one claw.
Yep, these two lethal weapons. You have to have your claw short enough that it would be allowed on a flight.
It needs to be able to regrow. I need to have to like clip it, like when you have to clip dog's claws, and then you have to regrow. Oh, there's got to be an animal that I can. Yeah, because surely cat's claws grow, right? So yeah, I just need like a leopard paw, jaguar paw, get the claw.
Just file it down before you get on a plane.
But they'd never know, would they? Because it's retractable. So how would they know? They wouldn't be able to see unless, I mean, I'd be X-rayed, I guess, wouldn't I? Like, you know, put through the barriers, the security.
Yeah, unless it's something that isn't opaque to X-rays as well.
I'm going to find something.
I see your retractable claw and I raise you. I'm getting totally away from the biology-inspired thing. I raise you an alien mouth. You know the film Alien, where the mouth comes out of under the mouth? It'd be funny.
You just burst through like doorways at parties like...
I'd read that is actually inspired by a bit of biology. The lamprey eel has a jaw.
Horrible creatures. I had to dissect one, I think second year, third year. They're just gross. I'm sorry. I love and respect all animals, but lampreys are just horrible. It's literally a mouth with like a stomach, and they're just basically like a leech and an eel had a child. They're grim.
I guess that explains why this entire series of horror films that are set in space about an alien with a mouth in the mouth in a retractor, a hinged jaw. Guess that's where that comes from.
I mean, yeah, it's definitely like horror movie fodder.
And on that delightful note, having started off talking about material science that's inspired by nature and ended up talking about horror films and aliens, I think we should leave it there.
I think that's probably best.
So there are loads of materials that mimic things in nature, and they can be worn by us, some for outdoors pursuits, whether they're shark skin wetsuits that are inspired by nature but don't work in the way they're meant to, apparently, or are adaptive insulation inspired by squid skin that could be used for clothing or for coffee cup packaging. And we've also kind of mentioned some of the biomimicking materials that could be used to help with physical tasks like climbing buildings, and I suspect there are loads of others. So if anyone listening to this has bio-inspired material or something else that's bio-inspired that they really want to talk about, then why not let us know? We are on Twitter, we're on Instagram, you can email us, we're also on Reddit, and if your podcast player lets you, you can leave a comment on this episode that we will read and enjoy. Thank you very much.
Thank you.
The views expressed in this podcast belong entirely to the person that said them. They do not represent any industry or organisation. If you enjoyed listening to these views, it would really help us out if you could rate us, leave a review and tell a friend. This podcast was sponsored by no one, but if you're interested in funding us to continue to have frank discussions about science and engineering, please get in touch.